Assalamualaikum and hi everyone. I want to explain about my manual calculation on Fourier series circuit. Okay, my circuit is this, which is consists are 1 kilo ohm, capacitor 1 microfarad, and inductor 0.5 Henry. We get this graph. Okay. As we can see that the graph is an odd symmetry. So, we can simplify that A naught is equal to 0 and AN is equal to 0. From the graph, we find Ft, which is 100t minus 5 from 0 to 0.1. This. And 5 from 0.1 until 1. This. Then we substitute the Ft function into the n equation. Okay. We get this and then we separate by 3 parts, which is x, y, and z. By using integration by part at x, we get this value, and then we integrate y, we get this, and z, we get this value. Then we substitute x, y, and z into the original Bn equation, and then we can find Bn is equal to 10 over n pi in bracket 20 over n pi sine 0.1 n pi minus negative 1 power of n minus 1. Then we substitute Bn into Vt equation, into Vt Fourier series equation. We get the value Vn is this when n is 1, n is 3, and n is 5. Then change all RCL's component into impedance. By using mesh analysis, below on the circuit. Based on the circuit, we can use mesh analysis to find current and voltage at each component. So, on first loop, we get this equation and we simplify that Ia is equal to SVN plus 1 mega IB over 1 kilo S plus 1 mega. Then we do on second loop. We get this equation. Then we get IB is equal to this equation and we substitute value IB into Ia. Then we can find this value Ia and IB value. So, by using we know that Ia is equal to I impedance resistance. So, the current of impedance resistor is when n is 1, the value is 1.10999 multiplies 10 power of negative 4 and angle is negative 90.089999 degree ampere, and for 3 is the value and 5 this is the value. Also, by using Ohm's law, we can find voltage of impedance R, which is this value. And then we substitute the value of current and voltage into Fourier series equation, which is I impedance R this and voltage of impedance R is this value. Then we can find current and voltage at impedance capacitor, which is, we know that impedance on capacitor, current on capacitor, we can use this equation IA minus IB and we can get this value. Also, we use Ohm's law to get the voltage of impedance C. So we get this value. Then we substitute the value of current and voltage into Fourier series equation. Same goes to current and voltage at impedance inductor. We know that current on impedance L is equal to IB. So, we get this value and we use Ohm's law to get voltage of impedance inductor, which is this value. Then, we substitute the value into Fourier series equation. Then, we find power average at resistor. By using this formula, we can simplify that VDC times IDC is equal to 0 and we can find the value of power average, which is the value is 7.08 microwatt. That's all from me.
Okay, I will show you how I get the input, the current for the each component. First, we put at voltage. Voltage, and we see is the output. And the FFT at here. So after that, we want to see the current at resistor, and we run. The output is here, and for FFT, it's here. Okay. So we see the current at capacitor, run, okay, output, and use FFT. We got the graph like this. Okay, so for the inductor, put here and we run, we get this. And for FFT, get the graph at here too. Show you how to I get a voltage from each component right here. Then we run. We see the square wave and FFT at here. Okay, so we do the same thing at resistor. We run and get the square wave. We get here. For capacitance, we run the simulation and we get the square wave too. FFT, and so voltage at resistor, we run and we get the square wave for FFT like this too. Okay. Okay, we continue to know the input at the power of resistor. We put this resistor on. Sorry, we put here. Okay, and we can see the voltage. We run the graph that we get is here, and when we use FT, it's like this. Okay, thank you.